All right, so now we've talked about the UPS input substation F2. That substation feeds the UPSs. The UPSs then in turn send output power to a COD board, in this case COD F2. So each UPS input substation has associated UPSs and an associated output board. Obviously there's no transformer associated with this. It's not really a substation, it's just a switchboard. So each UPS, there's five modules per system. It's different than the existing. The existing has a system cabinet and all the modules send power to it, and then it sends power out to the load. Here there is no system cabinet, so all the modules feed directly to the COD board through these 5 breakers. Similar to the breakers down there, these breakers are all monitored by Convergent. But the input breakers do not have closed button cover plates because it's never unsafe to close those breakers manually. That's not really the case on the output. On these output boards, which are called MOBs, module output breakers, if you close them when you shouldn't, you can cause instability in the UPS system. So if one were to trip open, if for any reason this breaker opens on any of these modules, you should never reclose it with the associated module online and running. You want to close this breaker when the module is totally de-energized. So you close here and then you'd go and close the input breaker and start the module up. Failure to do that can cause the other modules to have a problem, and the reason for that is that closing this breaker is what tells the other UPSs that a module is part of this collective system. So if a module is running, but this breaker is not closed, the other modules disregard it. So if you take a module that the other modules don't realize is there, and then you instantaneously add it to the system by closing this breaker, the system will not respond favorably. It may transfer to bypass, may cause some synchronization issues. So it should never be done. So that's why this plate is here. And then also there's a red label that says, do not close this breaker with associated module running, refer to MOP. MOP being the MOP written by QTS for operating this gear. In addition, ground fault is disabled. When they ordered these breakers, they ordered them with ground fault protection. But the way that this system is relative to their existing, it doesn't lend itself to ground fault protection that won't cause nuisance trips. So it's very difficult to be able to place the neutral CTs in a location that would properly sense a ground fault and not trip when it shouldn't. So the decision was made by the engineer of record to disable ground fault protection at this point. The UPS modules themselves can protect in a faulted condition, so if there were to be a ground fault, the UPS should limit its own damage automatically and without the aid of a breaker tripping. So these 5 breakers have had that feature disabled, and there is a jumper which you don't really, the jumper from B6 to B7, and that's the jumper that disables ground fault. This jumper here disables zone interlocking, and this jumper here just jumps across what would normally be an input for a ground sensing CT, which is not present on this board. And I guess these wires here are the wires that go back to tell the UPS that's connected, UPS that's associated with this breaker, that this breaker is closed or open. So these wires here just communicate information back to the module about the state of this breaker. If any of these breakers opens for any reason, an alarm will be enunciated on Convergent. So if they're just not closed, if they're either tripped or just not in their normal state, which is closed, It'll enunciate an alarm. What's different about the COD boards in this case versus what you normally see at a substation or a switchboard is normally you have one main input, or you have two mains where one is closed and one's open normally, and then you can swap between the two like we have at the UPS input substations. But at the COD boards, we really have 5 mains. We really have 6 mains actually, because you have a maintenance bypass too. So there's a total of 6 sources for this board. 1 from each UPS module, and then a 4,000 amp, or I guess 3,000 amp maintenance bypass breaker, which is right here. So it's not intuitively obvious that that's the case. It's not intuitively obvious that that's the case. So you just need to keep that in mind. So power flows into each of these breakers, hits this distribution bus here, and flows to the critical load. So the next breaker when it's traveling along this path is the load bank breaker. The load bank breaker is 3,000 amps, and it is normally open, should never be closed when critical load is attached to the output further down on this board. It is automatically controlled by square D through the maintenance bypass system, and it has a close button cover plate. And in this case, there's a close button cover plate because closing it at an incorrect time could be unsafe. There's a sync check that checks voltage synchronization across here, and if you use the button to close the breaker, you defeat the sync check relay. So when you're in maintenance bypass, that's the only time that it's possible to operate this breaker using the square D system. But it feeds out to MS3, which MS3 then feeds the load bank, and you would apply load to an offline UPS system through this breaker. Should also, just a general note, in this system, there is bus duct, and the bus duct runs between each of the UPS boards and MS3, and each of the mechanical boards and MS4. And so if one breaker is closed, anywhere connected to that bus duct, all of the bus duct is energized. So if you're at a substation, or if you're in a COD board and you want to shut it completely down, it's hard to do that. Even if you were to lock out all these breakers, while the distribution bus would not be hot, the line side of that bus duct, either for the maintenance bypass or for the load bank, could be hot if any of the other maintenance bypass breakers are closed. And that's just not a typical situation on most boards, but it is here. So after power flows into this board from each UPS module, it comes down, it comes over, and it comes up through the isolation breaker, called the ISO breaker. And this breaker is meant to isolate the UPSs during maintenance. So during a maintenance condition, this breaker would be open, this breaker would be closed, and your UPS system would be isolated, and then you could do your load bank test or shut the UPSs down without affecting anything. As with the other breakers, these are all breakers that can be racked out. There is ground fault on this breaker, this breaker, this breaker, and that breaker. Unlike the ones here, it has not been defeated in these other locations. And I didn't mention this, but it's true at the UPS input substations for the main and the maintenance bypass. There are LED blocks that show the status of the breaker. Red on the right-hand side, red LEDs lit on the right-hand side is closed. Open LEDs on the left-hand side, which show up green, indicates the breaker is open. And if the breaker trips due to an overcurrent, it will blink yellow here and here. Up here we have 3 sync check relays. Each relay looks across a different breaker. So device 25-MB, ISO, and LB refer to the maintenance bypass breaker, the isolation breaker, and the load bank breaker. So in each case, the sync check relay is looking from the source side of the breaker, which is called the line, and the bus side of the breaker, which is the load side. And it indicates live line and live bus just like it did at the UPS input substation. Just like the UPS input substation, you can take these out, slide them out, put a new one in. These relays are not set the same. The load bank sync check relay has a 0-degree sync window because you are never to close the maintenance bypass, the load bank breaker, if the bus duct that it feeds is already energized. You would always want to be energizing a de-energized bus duct. So the bus side of this breaker, which is the bus duct itself, should be dead whenever this breaker is closed. So sync check relay won't allow you to close it if both sides of the breaker are hot, even if they're in sync. The other two breakers allow live line dead bus closures, so that if the isolation breaker is closed but the modules are all off and you wanted to go to maintenance bypass, you could do that. It would close this breaker and open that breaker. And then likewise in the opposite direction. And I meant to mention this at the UPS input substation. We've color-coded the relays. Must have fallen off. I guess the stickers must have come off right there, but if you look here, there's a yellow dot, and a red dot, and a red dot, and that's just to tell you that this relay is associated with this location in the board. And since these aren't set the same, it's important that this relay goes back where you got it from. Same thing for here. I'll add some yellow dots up there. They should be there. They're not. You open this cabinet up. Across the top there are PTs. That's for your sync check relay sensing. You've got more black breakers that are for the DC distribution, which powers all the trip units of all the breakers. And then you've got a best battery set of diodes in there, and then you've got switches to disconnect PTs. Up there, your field interconnect wiring. There's the communication module. Communicates all the breakers back to convergent. All right, now in this case there are two separate SEL relays. I don't really know why they chose to use this model relay here and a different model over there, but they did. The real difference between these two and that one is that one has essentially two relays embedded into one box. Here they use two separate relays. So one relay handles an overcurrent on the main bus coming from UPS modules, and the other one handles an overcurrent on the maintenance bypass source bus duct. So it'll send something to square D to the effect that don't transfer, we have some sort of an overload. In this cabinet, we have all the relaying and PLC input hardware for operating the breakers in this COD board, and they're all associated with the Square D maintenance bypass system. So it says right here, Power Logic COD F2, Power Logic meaning Square D Power Logic system. So these right here, these relays are the ones that actually operate the breakers. This is the PLC inputs and outputs. Phase one, this cubicle, there is no Square D cubicle located in each COD. In this phase there is. And then this is just a spare breaker that they could pull out and plug into one of the other cubicles. It's a 3000 amp breaker, and it's supposed to be set up the same as these two. So normally this breaker is open. It's monitored by Convergent, but it doesn't feed anything, and it's normally open. So they could either choose to use it as a replacement breaker, or they could add a future feeder out of here to someplace else. So normal power flow, like I said, comes from the 5 breakers, comes through this breaker, comes up here, hits the main bus, and then this is what feeds the input to all the PDUs on the data floor. In this case, for this system, I think it can feed a total of 24 PDUs. There's breaker provisions for that. At this point, there's only 7, I believe, that are installed. They may have added some since I was last here, but from all I know, that's how it is. Overhead, there's a breaker lift, the same as the one at the UPS input substation. It can be used to take any of the breakers out.